Hi guys, we are going to go ahead and continue with section 8.1.1. It does have a day 2 on it. So this section is all about how to start sketching graphs of functions, and it really is just about getting to know the shape. If you remember from the last video, we had to type our function into the calculator to know what the graph was going to do, how it was going to start, how it was going to end, and now we're going to learn how to know those things without the use of a calculator. So basically the end behavior of a function describes the behavior of the graph at the ends of the x-axis. So basically that's where it starts and where it ends. It's just on the left of the x-axis and the right. So I have a fun SpongeBob themed visual here for you to kind of get this idea across. Here, if you look at SpongeBob and Patrick's arms, they're both raised up towards the sky, right? So an example of this would be like a parabola, right? Because it starts going up and it ends going up. And you can see that if I just kind of draw it in here. And this would be called like up, up. All right. And then here, you can probably guess, now SpongeBob's arms are both pointing downwards. Okay, so this, maybe an upside down parabola would be an example of this, and you can call this down, down. All right, here we have another one. We have one arm on the left going downwards, and then we have the other one on the right going upwards. All right, so this would be called down, up. And we read graphs like we read a book, so left to right. That's why we start with down. And an example of this, actually cubic functions are a good down-up example. And then here, we have the first arm is up and the second arm is down. So this one is an up-down. All right. This one we could use another cubic function, but it would just be upside down. Okay, so just to give you an idea about what we're going to be working towards here. So, to find the method to the madness here. So this table is going to be a good way to sort all the different pieces you have to pay attention to when you're trying to figure out end behavior. So the two things that you have to focus on to figure that out are the leading coefficient, which we talked about earlier in 8.1.1, as well as the degree, which we also talked about earlier in 8.1.1. So if the leading coefficient is a positive number, and the degree is even, then we know our end behavior is going to be up, up. Okay, so we got up, up here. Okay, and these boxes are all just combinations of these ones. So this is even positive. And then here, if our leading coefficient is negative, but our degree is still even, then we are going to go ahead and say that this is going to be down, down. So both ends of our graph are going to be pointed downwards. Now for odd degrees, it's a little bit different. Now this is where we get into the up-downs. So when our degree is odd and our leading coefficient is positive, that's when you know you're going to have a down, up. Okay, so we're going to have a down and an up. Okay, and then for a negative leading coefficient with an odd degree, it's going to be like a flipped version of that. It's going to be up, down. So the left side's going to be pointed up and the right side's going to be pointed down. And on the next page here, I've also given you another visual to look at. Some people really like this visual. It has some examples as well. So just make sure you pay attention to the fact that this table is a little switched. Here the degree is at the top and the leading coefficient is on the left. but it has the same concept. So when you have an even degree and a positive leading coefficient, then you're going to be up, up. And an example of that is y equals x squared, because this leading coefficient is 1, which is in a positive number because there's no negative sign, and the degree is 2, which is an even number. Okay, or here, x to the 9th, it's an odd degree because the number 9 is odd, and it's positive because there is no negative sign up front. Okay, and then down here, this is where we get into the negative leading coefficients. So if you have a negative sign up front and the degree is an even number, that would be your down, down. And then similarly here, we have a negative up front, so the leading coefficient is negative, but the degree is odd. And that tells us that we're going to be up, down. So this table is also really helpful to put that all together. So let's go ahead and try some examples of how to use this. So here are some polynomials. We're just going to go ahead and look at the leading coefficient, whether it's positive or negative, find out if the degree is even or odd, and then make our decision accordingly. So the leading coefficient, as we talked about before, if there's no number up here, it's just automatically a 1, but we don't care about the number as much as we care about the sign. So since there's no negative out here, we're going to go ahead and say that it's positive. If there was a negative, that's when it would be negative. Okay, and the degree, we have 1x here, and we have an x squared here. So x times x squared, that gives us an x cubed, which means that our degree is 3. 3 is indeed an odd number, so we're going to say that we have an odd degree. Okay, now let's go ahead and look back at our table. We have a positive leading coefficient and an odd degree. Positive, odd, that tells us that we are going to be down, up. And we can look at this table too. Odd degree, positive leading coefficient, down, up. So we will write down, up. All right, let's go ahead and try another one. Here, this time our leading coefficient actually is going to be a negative number because it has a negative up in front of the parentheses. So negative. And the x's here, we have 1, 2, 3. There is an x squared just like the last one. So again, we have x times x squared gives us an x cubed, and this is our degree. So once again, we have a degree of 3, which is odd still. And now that it's a negative odd, we can go back to our table and find that negative odd gives us up, down. And again, to find that on this table, you go to odd and negative, and then find the box where that's the combination. So we will go ahead and write up, down. Okay, moving on to the next one. Here it's in standard form now, so to change it up a little bit, the leading coefficient is the number attached to the term with the degree. So really for all of this, we're just going to be paying attention to this term. The leading coefficient is positive because there's no negative sign here. And then the degree is 4, which is an even number. So we'll put even. And so positive, even. We move back here to find that positive even gives us an up, up end behavior. So we will go ahead and write up, up. Okay, and one last example here. Notice that there is a negative sign out front. If we were to factor that negative sign into this whole polynomial, we could actually rewrite it as negative x to the 4th minus 2x to the 3rd. It would change all the signs on everything. So anything positive will turn negative, anything negative will turn positive. So plus 13x squared plus 14x minus 24. And again, we just changed all the signs because of this negative out front. So this tells us, now again, we're paying attention to this term, the leading coefficient is a -1. So that's where a negative's coming from. And the degree is 4, once again, just like the last one. So it's an even number. Okay, and negative even, that's going to be similar to this one, it's just the opposite. It's going to be down, down. And again, you can refer back to your table to figure that one out. And that is pretty much the gist of end behavior, just focusing on that first term and looking at whether there's a negative sign and figuring out whether the degree is positive or if it's negative. That's all.